Sorry. Okay, so now in the previous hour we kind of like using this interactive tool to help us estimate the probability, right? Okay. But actually, when the scenario is easy, right? It's kind of handy to use this interactive tool, right? But usually you do not have this interactive tool in hand, right? And writing this the app is actually quite time consuming, right? Okay, so usually we will simply use R programming, right? For example, we'll use this R programming to make the analysis and then make the decision. Okay, so if you go to RStudio, now you can see that because you are running the app, right? So you'll see the red line here. Okay, so for now we want to switch to 2AX RMD. Okay, so far we are running 2A RMD, right? But right now I want everybody to switch to 2AX RMD. Okay, okay. But before that, you need to close the running app, right? By press this button, it will close the running app. Okay. And then of course after you stop the running app, the browser is no longer active, so we can close that. Okay, and let's go back to the take a look at this 2AX HTML. Okay, so in the beginning I have some code that actually build the model and build the the PDF function. Okay, PDF is actually this density probability density function, right? Okay, so as I told you, we don't really have time to. It's actually not difficult, right? You simply just do this to estimate the density function. Okay. And so I would like to focus on how to use this probability function to calculate the probability, right? You have this PDF, but this PDF is actually this curve, this yellow curve, right? But in order to calculate the probability of between the two boundary, then you basically need to do the integration, okay? And give it like x1 is this value. Well, this expression would actually calculate the probability that the next event would occur within the boundary, within the period of x1 to x2. Okay, that's how this PDF works, right? You need to calculate the area under the curve. Is the probability, okay? The area under the curve from the left tail to the right tail would add up to 1. If you do an integration from from the left tail to the right tail, the area actually sum up to 1, right? It's density function, right? So all of the things, if you take all of the possible value, then the probability is 1, right? But if you only want to calculate the value within a certain period, this is the way to calculate the value. Okay, you need to do an integration. Okay, do you still remember calculus? Okay, but don't worry about that, right? In R, it's simply an expression, right? Then you can calculate the probability value. Okay, so and then with that, we can actually try to use the programming, right? Try to use the programming way to help us do the strategic planning for case number 1, right? In case number 1, as you remember that we want to find a 1 minute period, right? So where the probability is the highest, right? Okay. So in order to do that, we can use the these 3 lines of code. Let's go to RStudio. Okay. 2AX, and then I would suggest you you can press this button, right? Scroll down, and then press this button. It means I want to run all the chunks above, right? So scroll down to case 1, and then press this button. It will run all of the chunks above, so you can actually build the PDF. Okay. And then now you can see this is the way to calculate the highest probability period, right? First of all, we do a sequence, right? We use this function a lot of times, right? Okay, so we specify 0, 5, and 0.1, which means that start from 0, I will have a sequence, right? I will have a sequence from 0, 0.1, 0.2, up to 5.0, right? So this is the first time, because we want to use that, right, to calculate the probability of this 1 minute period, right? So as you can see that I'm using sapply and give it x1. So for every value, for every one of this value, you actually use this expression, the expression that we had explained it before, right, to calculate the probability of that of the corresponding 1 minute period, right? Okay, so see that this sapply is kind of very useful when you want to do a repeated action, because we want to test from 0 to 1 minute, from 0.1 to 1.1 minutes, right, and up to 5 minutes to 6 minutes, right? Okay, so you want to repeat all of these things. So the easiest way is to make a sequence first, and then you use the sapply to apply every element of this value to this function, and then we will get P, right? We will get a number of P. Let's see the value of P. It's like sorry, I think I had that from this, yeah. So after we run it, you can see that P is a vector of 51 value, right? So actually we can build a data frame and make it easier, right? Let's see this data frame. See? Now, for every starting and stopping time, we will have a probability, right? Isn't it? Right? So within this data frame, we simply choose a 1 minute period which has the highest probability, which is, as we see, this one has the highest probability, right? From 3.9 to 4.9, okay? And it has the highest probability of 0.476, isn't it? Right? Okay? So if you do not have that interactive tool, right? The way to do it is to first of all, we need to build a sequence, right, for the starting time. This sequence is for the starting time, right? And then you use this, you apply that, use as apply. You can, for every starting time, you can actually calculate the ending time, right? Plus 1 minute, 60 seconds, right? And then use this expression to calculate the corresponding probability, okay? And then you can put the starting time, ending time, and probability in a data frame, right? And because we only want to see the top one, right? The top one probability, right? So if I execute this, I'll see that the starting time is 3.9, stop time is 4.9, and the probability is this one, right? So this is the way that we use program to solve the business case of case 1. Any problem so far? Okay. Now, let's take a look at the second case, right? Second case is a little bit more complicated, right? Now you can bet on multiple bet. You can place multiple bet, $5 per bet, right? And you can bet on every 10-second period, like 0 to 10, and like 3 minutes 20 to 3 minutes 30 seconds, right? So still you will win $100 if the next Russian fall within the period that you have chosen, right? So now we want to find the best strategy. What is the best strategy? It's the strategy that would generate the largest expected value, right? Isn't it? Right? So, but in order to do that, you need to calculate first of all, you need to calculate the probability of every 10 seconds. Isn't it? Right? Right. So, so this is the problem, right? It's kind of like very short. Okay? Let's see how we do it. Okay? Let's see how we do it. Now, first of all, we need the sequence, right? Isn't it? Because we want to calculate the probability for every 10-second period, right? So first of all, we need to specify the starting time, right? Okay? This time I start from 1 and end at 6. And 1/6 a minute, because the unit is minutes, right? So 10 seconds is what, like 1/6 a minute, right? Okay? So this is the, like, I put the starting time here, right? And again, I use as apply to, like, for every starting time, we calculate the, like, as you can see that I use infinite here and calculate to I, right? And I is one of this value, okay? So first of all, this is the idea of so-called CDF, right? Okay. So it calculates from the left tail, right, to, well, the idea is like this, okay. Okay, this is the PDF, right? So if I want to calculate this period, okay, we basically have two ways to do that. right? The first way is like do integration on every on the boundary, right? Okay, and the other way is to calculate the cumulative probability function, okay, right? So, and the cumulative probability function is actually like for every boundary for x1, I calculate the probability from the left tail to x1, okay, and that is the value here, okay, and then I calculate the probability from the left tail to x2, and the value is here, right, and I deduct the two values, then I can see the probability, okay. Well, this is actually if you learn probability or you learn statistics, this is basically how PDF and CDF works. You have taken course of probability or statistics before, right? Okay, so you should still have some concept, right? Okay, so in order to calculate the probability with PDF and CDF, the way is like the most convenient way is actually build CDF first, okay, and the way is to calculate the probability from the left tail to the boundary, okay, and that is what we are doing here, right? The left tail is like I put it like in negative infinity, right? So it's the left tail. So and I actually specify the boundary from 1 to 6, right? For every 10 seconds, right? So in CX, I actually have the probability from left tail to every boundary value, right? Okay. So next thing is like as you can see that I build a data frame, right? Okay. So the start time is x, right? Minus 1/6. Okay. Start time is x. Okay. And the probability is cx minus leg cx. Okay. Because in this expression, I actually have already calculated the CDF value for every 10-second boundary, right? Let me say it again, right? See, in this expression, because I already have a sequence of 10 seconds period boundary time, right? And I can actually use this, I can actually calculate the CDF value for every 10-second boundary time, right? And then I can use CX minus leg CX, right? In this way, I basically can calculate the probability for every 10-second period, right? For example, if this is 1 minute 10 seconds and this is 1 minute 20 seconds, right? And I know the CDF value, I simply like minus the CDF of x2 to x1, right? So this is a way to calculate the probability for every 10-second period. Okay? Well, in R, it actually only takes like a few lines, right? So to build a data frame, right? If you know how to do it, right? You only take like a few lines of code to calculate the probability that associate to every 10-second period, right? So if we run this, right, and then we see this data frame, now we will see like for every starting time, right, from 1 minute to 1 minute 10 seconds. This is 1 minute to 1 minute 20 seconds, right? 1.5 30 seconds, isn't it, right? So there's a corresponding probability for each of this 10-second period, right? Okay. So now we know the probability of each of this 10-second period, right? We can calculate the net payoff for each of this period, right? And we simply do a mutate, isn't it? Right? We simply need to do a mutate because the net payoff, if I bet on this 10 seconds, the net payoff is the probability times 100, right? Minus 5, right? 5 is the cost. If I bet on this one, right, the cost is 5. But if I bet on this one, I will have a negative payoff, right? Isn't it? See, and in order to calculate the payoff, the beauty of R programming is that you simply use one line of code, right? So you can actually turn this, you can actually calculate the net expected profit to bet every 10-second period, right? And put it on the data frame. So if I see this, I'll see data frame like this one. Let me calculate the data frame and see it here, so it's easier. Right? So your data frame like this one, okay? If I bet on this 10-second period, this is the net expected value, okay? Do you want to bet on that? Why? Why not? Do you want to bet on this period? Sorry, this period. You see the net expected payoff, right? If the net expected payoff is negative, then you don't want to bet on it, right? Isn't it? Right? See? As I say that when you are facing uncertainty, okay, you will make a decision by the expected value, right? When the expected value is negative, you don't want to do it, right? So here, as you can see that these are negative, but starting from here, you will see a few positive ones, right? And then it go back to negative again. And here you will see some positive one, right? Okay. So for most of the 10 seconds, you don't want to bet on it, right? But for some of the second that has a positive payoff, you want to bet on them, isn't it? Right? So let's go back to the code. As you can see that after I calculate this data frame, the next thing is I filter out the payoff, right? I only want to bet on the payoff that bet on the period whose expected payoff is larger than 0, right? So we have like this many, we have 9 period who have a positive payoff, right? And I actually do a sorting, right? Sorting by start time, okay? So this is the bet. And then we can see the bet. So we can actually see the time, start time, stop time, right? And their expected value, right? Okay, and you can see that if I change the number of rows of bets, right? It's actually we can see how many period we want to bet, right? It's actually 9 period that we can bet. But if we bet on this 9 things, right? So what is our expected net expected payoff? It's actually 24.28, right? Which mean that under the scam rule, if I can bet on any one of the 10-second period, right? Okay, and then every bet I need to pay fine. And if I hit, I will win 100, right? The best strategy is to bet on this 9 period, okay? And the net expected payoff is 24.28, right? Okay, it's more flexible, right? The rule is more flexible. So like comparing to the net payoff of 17.6, right? Compared to that, you only have choice on like 1 minute period of time. You now can like actually bet on every bet. So you have, first of all, you need to choose how many bet you want to bet, and then you can calculate the, right? If you want to bet 9, then you have a cost of like $45, right? It's some kind of like your investment, right? Okay, but with this $45 of investment, you actually can expect to have a net expected value of like 24.28. Okay, so that's the way that we use program to make decision, right? And if you see here, the code is not actually very complicated, isn't it? Right? As long as you know how to do it, okay? As long as you have a clear idea about your business logic, right? So as long as you have some programming capability, right? Isn't it? Right? So it starts with like we build a sequence for all of the choice, right? And then we can calculate the probability for each of this choice. Okay? Here actually, right? We calculate the CDF first, and then with that CDF, we actually can calculate the, for every start time and end time of 10 seconds, we calculate the probability. And then with one line of code, we calculate the associated net expected profit. Okay? And with that, we can very easily make a choice, right? With this data frame, then we can simply fill out the period which would generate a positive expected value, right? Okay, so and that is what we want to bet, and this is the number of bet we want to place, and this is the expected value, right? Net expected value that we expected from this game. Okay, it's not bad, right? Because you only invest like $45, and you have a net expected value of 24.28, 24.28. Now, actually, if you use this strategy, every time you need to spend $45, right? Because you are placing 9 bets. The $45 is fixed. It will not vary. But at the end, you will either win $100 or lost $45, right? For every trial. Okay. For every trial, you will not get 24.28, right? You will either win, right? If you win $100 and minus the cost, you win 55, right? And if you lose like $45, okay? But if you think about the probability that you might win, it is actually how to calculate the probability of you win. It basically just like sum the probability, isn't it? Right? So you actually have a very high probability to win, right? Isn't it? Right? It's about like 70% of time you will win the trial, and you will have 30% of time to lose. Okay? Get it? Okay. So this is the way to do the business scenario that we just expressed. Okay? Now, and the next thing we want to see is that sometimes in business we will consider the ROI, which means the ratio of expected return versus the amount of their investment. Okay? I mean, sometimes in business we are not only looking for the maximum expected profit. We also want to consider the amount of our investment, right? Okay. If I invest a lot, then I may not have enough of time to bet for 9 bets, right? Okay. So sometimes you were you need to consider the number of bets, right? Sometimes you will need to like, as you can see that from DF, I arrange by decreasing payoff, right? And I do a mutate to mutate a few more columns, right? The first column is the number of bets, right? Okay, it's the raw number, right? Okay, and then the investment is number of bets times 5, right? Because every bet you need to pay $5, right? And the payoff is the as you can see that I'm using this payoff and do the cum sum on the payoff, right? Okay, and then I want to calculate the cumulative. This is the cumulative. C implied cumulative, right? So let's run this and see the result. You will have a better idea. Okay, let's see that. So as you can see here, now we have, because I already sort the data frame with the probability, right? So this is the highest probability. This is the second highest probability period, right? Okay. So so if I can only press one bet, I want to bet on the period that has the highest probability, isn't it? Right? So if I have the enough of money to press two bets, I will bet these two things, right? And if I press two bets, my cost would be $10, right? Isn't it? Right? And then my net expected payoff would be like 8.499, right? Isn't it? Okay? Because I need to add this 469 to this value, right? So these two values add together is 499. If I press 3 bet, and I actually need to add 499 to 3947, right? And this can be done by using this COM-SUM function, right? The COM-SUM is actually like for the first thing is equal, it's the same, and for the second thing is actually the sum of the two, and for the third thing is actually the sum of these three, and the fourth row is actually the sum of the four, right? So this is the cumulative payoff and also the cumulative investment increased by the number of bets. Get it? Any problem? No problem, right? Okay. Because the number of the cumulative cost is actually the number of investment, right? The number of bets. And the cumulative payoff is actually the cumulative net expected payoff, right? And then I can see the cumulative ROI, which is the payoff over investment, right? Which means per dollar of investment, how many payoff can I expect, right? So in business, sometimes you are looking for highest payoff, right? Sometimes you're looking for higher return on investment. Okay, it's a different concept, right? If you have unlimited capital, right? You have unlimited money. Of course, you can bet on every period that generate a positive payoff, right? But in the other hand, every company has only a certain amount of money, right? So you might have constraint on your investment, right? And another case is that you may have another investment opportunity who generate a higher ROI than this one, right? So this is a business opportunity, and you also see some alternative, some other business opportunity you can invest on. So, and you want to compare the ROI, right? If the other business, although I invest on this, I can make money, but there is another business that if I put my money there, I can earn more, even more, right? So in that case, you don't want to spend money on this less profitable. You want to spend money on that more lucrative business case, isn't it? Right? So ROI is also important consideration, right? So in this case, I actually calculate the cumulative investment and also cumulative payoff, cumulative ROI. So as you can see that the cumulative payoff is rising, right? But after from the 1st to the 9th, it's always increasing. But actually to the 10th, as you can see that the expected payoff is becoming negative, right? So we would the more than 10 to bet on more than 9 period is unreasonable, right? So this 9 strategy is reasonable, right? But as you can see that although its payoff is increasing, its ROI is decreasing, right? Okay, because the overall probability is decreasing, isn't it, right? So the ROI is decreasing while the payoff is increasing, right? And in this case, when we have multiple business objective, right, we usually can do some visualization to help us make the decision. Okay, so here as you can see, I use ggplot and I map the cumulative ROI and cumulative payoff to the X and Y coordination. Okay, so this is the cumulative ROI on the expected ROI on the x-axis, and this is the expected payoff, right? So ideally, you want to have high ROI and high payoff, right? Okay, but as you can see that from this is the number of investment, right? When it's green, that you invest only a little money, but when it is red, you invest a lot of money, right? Okay, so can you see from this graph, from this plot, can you see the reasonable and unreasonable strategy? We can see some of this strategy are unreasonable, right? Because if you see a point, right, this is the strategy space, right? This is the idea of strategy space. In one way, we want to have a high expected payoff. In the other way, we want to have a high expected ROI, right? So here is the ideal point, right? Okay, on the upper right, right? This is the ideal point, right? So actually, from 1 to 9 are reasonable choice, but they are a trade-off, right? In this 9 strategy, okay, the higher the ROI, the lower, the higher the expected payoff, the lower the ROI, right? Isn't it? Right? See, if I choose like 9 bet, I can have an expected payoff of about $25, but my ROI would be like about 0.5, right? Because in this case, I invest $1, I can expect a return, net profit of about $0.5, right? But if I press only one bet, right, for every dollar I invest, I can expect like about more than 8, right? More than $0.8, right? So this ROI is higher, but actually its net expected payoff is lower. It only have a net expected payoff of $5. See that? Right? Okay. So this is a trade-off, right? This is a trade-off. As you can see that, right? So if this in this trade-off, we can make a choice, right? You actually can show your boss, right? You can tell your boss that if we press one bet, we can press only one bet, which will have very high ROI but very low expected payoff, and our cost of investment is low, right? But if we increase our investment, right, okay, our ROI is dropping, but our expected payoff is increasing, okay? And this ROI, this net payoff will increase up to the point that we invest 9 period, okay? And if we invest more than 9 period, both ROI and expected payoff are dropping. So we don't want to invest on this one, right? Except 10, this strategic option become unreasonable, right? Because both ROI and expected payoff are dropping, right? Isn't it? Right? So this is trade-off. As you can see that, you can see. So here, we can kind of make a trade-off and constraint, right? See, so if there's no constraint, what is the optimal strategy? Or it's hard to say, right? If your strategy is to generate the largest profit, then this is the one that you can choose, right? Okay, but sometimes you will have a capital limitation. For example, your investment cannot higher than $40, okay? And as I say, sometimes you will have another investment opportunity with a higher ROI, right? Okay, and in that case, you can use this strategy space as a communication tool, right? To discuss under the constraint and how you make the trade-off, right? How to make the best decision, how to make an optimal decision that fit into the constraint and like fit into your best company interest. Okay, and that's it. Is already 11:58. Let's do a very quick read up of what we learned today. Okay, today we start from data, right? And we use that data to build a model, okay? And we use let's go back here. We use data to build model. We use model to predict probability, right? And with this predicted probability, we can actually calculate the expected outcome of every strategic alternative, isn't it? Right? That is the ideal of business decision making by building model and doing prediction, right? Okay? Now, starting from next week, we will go back to predicting. We will teach you 2 different prediction models. One model, we can predict the numeric value. For example, I want to predict for each customer, I want to predict the amount of buying, right? If he comes to our store, okay? That is one type of prediction. I want to predict the value, right? The amount of buying. And the second type of prediction is to predict the probability, like what we did today, right? For every customer, I want to predict the probability that he will come to our store, that he will buy from us in the next month, okay? And with these 2 prediction available, we can try to design our strategy, right? we can try to like select our target marketing subject, right? And we can also estimate the expected payoff when we apply some marketing instrument to some group of customers, right? We want to estimate the expected outcome, right? And in this process, we can actually choose a set of good marketing instrument, right? We can design and choose a set of good marketing instrument that we can apply to certain group of customer and calculate their return on investment, right? That's what we are going to do for the following weeks, okay? That we are doing. Today is just a kind of like a warm-up, right? As I told you, you don't really need to learn too much about probability and things, just a very intuitive way of using probability, okay? So, and the tricky thing is we want to use data to build model and use model to do prediction, right? Okay, and that's what we're going to discuss starting from next week, okay? And at the end, we will go back to this scenario that when we can predict the probability, we will have an idea about the uncertainty in our business logic, so we can estimate expected outcome for every action we take, and with that, we can do a good business decision. Okay, that's the point of data-driven decision, and that is the purpose of business analytics. Okay, that's all for today. Any question? If no question, that's all for today. I'll see you next week. Remember to turn off your computer, right?